Hello ladies and gentlemen, welcome to my video. So this is today's question. A definite integral involves a fraction with exponential at the top and at the bottoms. Where do we start? Before we start, the advice is do not use partial fractions. As expected, we're going to start with substitutions. Define u equals to e power x, therefore du equals to e power x dx. dx is equals to du divided by u. For the new integration bound, when x approaching infinity, u equals to e power infinity, which is approaching infinity. When x approaching negative infinity, u equals to e power negative infinity, which is approaching 0. So we have a new q, which is equals to integral 0 to infinity, u power 3 divided by u power 4 plus u power 2 plus 1, and then the whole thing multiplied du divided by u. Of course, we can further simplify and then label this equation as equation 1. Now what? Our good friend inverting variable structure G. Change the u become u power negative 1, therefore du become negative u power negative 2 du, infinity becomes 0 and 0 become infinity. We obtain a new q, which is equals to integral infinity to 0 u power negative 2 divided by u power negative 4 plus u power negative 2 plus 1, and then the whole thing multiply negative u power negative 2 du. Cancel the negative by swapping the integration bound. Also, we include the new term, which is multiply u power 4 divided by u power 4. From here, we obtain q equals to integral 0 to infinity 1 divided by 1 plus u power 2 plus u power 4 and then du. Label it as equation 2. So integration bounds and denominator are the same. As usual, we will apply equation 1 plus equation 2. Therefore, we obtain 2q equals to integral 0 to infinity u power 2 plus 1 and then divide by u power 4 plus u power 2 plus 1 and then du. At this moment, there's no clue how does it help for the solutions. Let's include a new term, which is multiply u power negative 2 divided by u power negative 2. So the numerator of the integrand become 1 plus u power negative 2, while the denominator is u power 2 plus u power negative 2 plus 1. For the constant 1 in the denominator, we rewrite as negative 2 plus 2 plus 1. This is to complete the square for the first three terms. Consider the first three terms of the numerator. It can be rewrite as u minus u power negative 1, the whole thing power 2. And then plus 2 plus 1, which is 3, or square root of 3 power 2. While for the numerator, it can be rewrite as differential of u minus u power negative 1. This step is the same if you substitute t equals to u minus u power negative 1. So now we have q equals to 1 over 2 multiply 1 over square root of 3 multiply inverse tangent of 1 over square root of 3 and then multiply u minus u power negative 1. Replace x equals to infinity and 0. We have 1 over 2 square root of 3 and then multiply inverse tangent infinity minus inverse tangent negative infinity. We know inverse tangent infinity is pi divided by 2, while inverse tangent negative infinity is negative pi divided by 2. That brings us to the conclusion of this video. The final answer of this question is pi divided by 2 square root 3. Thank you for watching my video until the end. Please continue support my channel. Subscribe, give a like and share my video with others. See you tomorrow for another video. Bye bye.